Okay, this is the Math 9 lesson for section 8.0. I call it 8.0 because it's actually not in your textbook, but these are some geometry things that I think you should know before we start doing chapter 8. So if you have your notes with you, please bring them out and copy things down. Throughout the video, I might ask you to stop and pause the video. And if I do ask you to do that, please do that and try the questions on your own before playing the video and seeing the results. All right? Here we go. So the first thing I want you to understand is how to identify and name angles. So in this particular picture here, I hope you see that there are 3 different angles. I don't know if you can notice what they are, but the first one I'll say is this one, FRE. So we use the angle sign and we go FRE. That's how we describe that angle there. I'll ask you to try to give me another one, and if you said angle ERD, that's cool. By the way, you could also switch it around and start with D, then go R, then E. That's fine. And can you spot the third angle? You bet. If you said this one, angle FRD. By the way, when there is more than one angle meeting at the same vertex, in this case R, we don't name it with a single letter. So I don't know if you've seen stuff like this before where they just say, oh, here's a diagram, that's angle A. And that's okay because A is the only angle that I see there, but in our particular example at R, you'll see that there are more than one possible choices, so therefore we use 3 letters. Okay, angle classification. Don't know if you remember this from elementary school, but angles can be classified using these names. Something that less than 90 is what we call an acute angle. An angle that exactly equals to 90, you bet, we heard it a lot in grade 8, a right triangle, or right angle, sorry. An angle between 90 and 180 is called an obtuse angle. And finally, an angle that looks like a straight line, yeah, it's a straight angle. And that's 180 degrees. Some properties of angles. Yeah, we're moving fast. So there's something called the congruence property. That just means angles with the same measurement are congruent. Congruent just means same. So in this case, angle X, you look at the diagram, says 45 degrees, and angle Y is also 45 degrees. They are the same, so we write it as angle X, and the congruent symbol is an equal sign with this curvy little line up top. So that's the sign that says congruent. So it's congruent to angle Y. And by the way, we can also indicate that on the drawing. A lot of times we just do a little curve here and a little curve here. That shows that those two are the same. Some more properties besides the congruence one. There's the addition one. The sum of a larger angle can be determined by adding 2 or more smaller angles. So you look at this diagram. Can you see my small angle here? It's angle SUB, the sub. And can you see this other angle here? BUM, the bum. Did I just say bum? And if you add them together, you get SUM, the flat angle there. Now it says here, since sub is 105 and bum is 75, this would mean that when I add them both together to get sum, the answer is 180 degrees. And that's kind of neat because angles on a line now add up to 180. So let me just write that down. Angles on a line add up to 180 degrees. Write that down in your notes too. By the way, if I'm going too fast, just pause the video, write things down, and then press play again and you'll catch up. So look at example number 1. It says use these angle properties to solve. So look at this and it says angle NAE. That looks like this angle here. NAE. So it involves both 58 and 30. So what's 58 plus 30? I think that's just 88. So the angle here is 88 degrees. LAG must be this one. Same thing. Let's add the 2 things together. 58 plus 30. Oh, also 88 degrees. And therefore, what else do you see from here? We're looking for angle NAL. That's this line. This is 30 degrees. What other angle is congruent to that? If you said this one, so write that down. Angle EAG. and they are both congruent since both of them are equal to 30 degrees. And here, the last one says angle NAG. What would that be? That would be this entire one here, which means all of these are added together. Can you say 30 plus 58 plus 30? That's just going to be 118 degrees. Okay, so just a simple application of using the addition property for angles. Turn the page when you're ready. Something called complementary and supplementary angles. Don't know if you remember these terms from elementary school, but complementary means that they add up to 90 or combine together. So in this diagram, you see angle Fig, F-I-G, that's 60. Angle G-I-J, that one here, is 30. These two angles are complementary because 60 degrees plus 30 degrees equals to 90 degrees. And also note that angle Fig plus angle Gij is just the entire angle Fij. So that's equal to angle Fij, which is 90 degrees. So how do we find the complementary angle to a particular angle? Remember, the two things add up to 90. So just take 90 and subtract the angle, and you'll get the other angle that's complementary. So why don't you try example number 2 on your own right now. I'm going to ask you to pause the video and try those. And when you come back, I'll have the answers for you ready to double check. Pause now. Did you get those answers? If you did, congratulate yourself. And we can move on. If you didn't, go back and change and correct your answers, and let's move on after that. That was complementary. What's next? It's called supplementary. So supplementary angles have a combined measure of, 180 degrees. And by the way, you need to know this, so box that perhaps, and I guess you should go back and box this as well. Those are important facts. So if they're supplementary, that means they add to 180. In this diagram, SUA is 120. AUP is 60. And of course, they are supplementary because 120 plus 60 is 180. And therefore, SUA plus angle AUP is equal to angle SUP. What's up? Or sup? Angles on a line always add to 180 degrees. I think I mentioned that earlier on the previous page. I guess it's so important I mentioned it twice. Once again, you go try and find the supplementary angles. For example, number 3. I'm going to ask you to pause the video once again and then come back and double check your answers. check your answers with mine once again. Do we agree? If so, let's go. On to the next page, of course. Alright, this one's an important one we'll see quite often. Something called vertically opposite angles. And vertically opposite angles are angles that are opposite each other when two lines cross. So in this case, if I were to highlight angle N here, that one and angle S are vertically opposite. So angle N is congruent to angle S, and similarly angle E is congruent to angle W. There's a neat idea because if you look at supplementary angles, like the angles N and E in this case, so I'm going to circle that, N and E, notice that they're on a straight line. The two angles add up to 180, and so on and so forth with the other cases too. I could now, instead of looking at that line, N and W, I could look at this line, so those two angles, N and W, add up to 180. Or I can look at W plus S, which would be this part down here, these two add up to 180, and so on and so forth. So you can use this angles on a line business quite a bit for vertically opposite angles. So, using that, can you find the measures of the missing angles in example number 4? I'd say to you, hey look, 129, that must be vertically opposite of angle T, so those must be congruent 129 degrees. Now you have choice of how you want to find E, but I'm just looking here on this line. So you see you got the angle 129 and the angle E. Both of them must add to 180, so E is just 180, take away 129, which is 51 degrees. And now how do you find angle F? There are many different ways, but I know that F and E are vertically opposite, so I'll say they must be the same, 51 degrees. There you go. Alright, part 6, angles at a point. Woohoo! Ooh, almost done this page. So when angles meet at the same point, this big dot right here, they add up to, if you said 360, you are correct. Angle A plus angle B, angle C, and angle D in this question come up to 360. So, we're going to use all these properties now and try to figure out more complicated questions, and you're like, whoa, it's so much. But don't worry, I think you can try it. I'm going to ask you to try this first on your own, so once again, press pause. And then once you've tried it, you come back and double check your answers with mine. Okay. I'll say angle M here is 3 angles on a line adding up to 180. So angle M will just be 180 minus 56 minus 63. And if you don't know how to do that in your head, no worries. Hello, calculator. 180 minus 56 minus 63, 61 degrees. Okay. Now once you did that, the rest, you have multiple ways of doing it. If you want to look and say, hey, vertically opposite, you see this? Vertically opposite, therefore N must be equal to 56. If you can't see it that way, you could have also done this and said, hey, these 3 angles here add up to 180, so go ahead and solve from there. Angle P, by the way, if you want to take a look, I look at P and say, whoa, it's a big angle. But notice this angle and 56 are supplementary because they must go on a line. So I'll just go 180 minus 56, and that's 124 degrees. Okay. Part B, angle A seems to be here. It makes up a right angle. It's complementary, so 90 minus 32 is 58. Angle B seems to be just this little part here. Okay, I'll use blue. So it seems to be complementary to that right angle. So 90 minus 28, that would be 62. Angle C, hopefully you see that B and C add up to 90 right here. So angle C must just be 90 minus angle B, which is 62. That gives us 28. And then you get angle D. Many ways you can solve this, but I look at angle D being the angle that is vertically opposite of angle A. Vertically opposite of A. So that must be the same as A. That's 58. E must be then the vertically opposite of the 28. and F is the vertically opposite of B. So those are your answers. And by the way, you don't need to solve it my way. You could have used complementary or supplementary angles here quite nicely and also solved for the missing values. Okay, I hope you're doing okay so far. Let's move on to the final page, and this will be the review, or the ending part of the review. This next part is actually quite important because in the chapter 8 we'll be dealing with triangles a lot. So hopefully you remember that the angle sum of a triangle, no matter what size or shape, the angles in a triangle must add to 180. So hopefully from here you can do examples number 6. Once again, you try it, I'll do it, we come back and check. I hope you're right. If we're right, we're good. If you're wrong, then figure out what you did wrong and correct your notes. 180, 70, 55. You can use a calculator here if you want. If you don't need to, that's even better. But if you're not too sure, no worries. Oh, 55 degrees. So angles in a triangle add to 180. So I'm just going to take 180 minus the 2 known angles, and that gives me my unknown angle. Part C is a little bit different. This little thing here just represents a right angle, so that means it's 90. 90 minus 39, that must be 51 degrees. Okay, angles don't have to be acute, they can be obtuse. In this case, what's 180? Take away 18, take away 21, about 141. And then comes some interesting spicy stuff. E, F, and then, whoa, G looks scary. All right, E. See those 2 dashes there? What does that mean? That means the 2 sides are equal. And I don't know if you noticed this, but when the 2 sides are equal, the angles opposite of them, so that's this angle here, angle A, and this angle, angle T, are the same. They are congruent. So angle A is equal to angle T. So if those 2 things are equal, how do we find out the missing angle? Well, just like before when we subtract, we'll subtract again 180 minus 42. That gives us, what, 138 degrees? So the 2 angles here must add together to be 138. So what's one of those angles going to be then? Well, if 2 of them are that, then we're going to divide by 2, and we'll get what? 138 divided by 2. I think that's 79, is it? Oh, no, 69. Yeah, 69. There you go. So each of those angles is 69, so therefore angle A must be 69 degrees. Okay? Know this well, because we're going to see this kind of stuff again in chapter 8. Okay. I could switch it up for angle F, or not angle F, question F. Look at question F. This time I gave you the 67. I gave you one of the angles that are the same, so you should then know that this angle down here is also 67. And then you can hopefully figure out angle P by just taking 180 minus 67 minus 67. 180 minus 67 minus 67 is just 46 degrees. Okay, star this one as well. We'll see those quite a bit. Alright, and your last challenge for today. Let's see if you can figure out G and H, all the missing angles. I would seriously like you to try this one on your own first. Do as much as you can and then come back and double check your answers. There are many ways to do these, so don't freak out if your method is different than your friends or your mom or dad's. So go ahead and try these, please, and I'll come back and give you the answers. Press pause. Notice this. What type of triangle is it when you have these 3 dashes? If you said equilateral, yay! And with an equilateral triangle, all the angles must be equal, so 180 divided by 3, of course, gives you 60 degrees. So 60, 60, 60. Angle D, I hope, is 120 because this is supplementary to B. So I'm line. Angle E, I hope you can find by looking at the complementary part. So that's 30. So complementary to C. And then I hope you can figure out angle F by just saying angles in the triangle. Add to what? 180. So 180. Take away 120. Take away 30. Leaves us with 60 degrees. No, 30 degrees. Brain's getting tired. And then this one over here, angle A and B. This is another isosceles triangle. So this is very similar to this one up here we just did. E. So once again, how do we do that? We're going to take 180, take away 52. So that's what, 128. Both A and B are the same, so we're going to divide it by 2. We're going to chop it in half, so 64. A is 64, B must be 64. Okay. Now you're going to find angle C, and so angle C is here. Hopefully you can see that angle C and angle D are the same, because here's another isosceles triangle where two equal sides. So if you can figure out D, then you can figure out C, and I can figure out D because angle D seems to be on a line. Oops, you really can't see that, can you? So hopefully for angle D, you can see this. Angle D, angles on a line, and they add to 180. So if you think about it, 180, take away 63, take away angle B, which is 64, that will leave us with angle D. So that's how we can figure out angle D. 180, take away 63, take away 64, bam, 53 degrees. And I told you D was 53, so what's C? Well, that must also be 53 because they are angles opposite of equal sides in the isosceles triangle. Let's finish this off. Angle E, well, that's the last remaining angle in triangle, so angles in a triangle add to 180. So 180, take away 53, take away 53, that's 180 minus 53, minus 53. How about 74 degrees? And item F, well, that is just the third angle in a triangle. So once again, angles in triangle, they add up to 180. I'll say 180, take away, and that's 63 with the right angle 90, and that would be 27 degrees. I hope this was a good review. You're going to need this stuff as we move on to chapter 8. And if you do want some more practice, come find Mr. Lee and we'll give you some more practice.